Hello, my name is Katie Cronin, and this is my Lab 11 radiative heating with a UV lamp, which is an expansion upon Lab 4. And so the objectives of this lab were to basically investigate UV radiative heating using a nail lamp or a UV source and everything. And so basically I would measure the transient heat flux and surface temperature, calculate the heat transfer, and then basically compare the actual UV lamp heating to the conductive heating from Lab 4. And so the theoretical topics that I wanted to cover were basically radiative heat transfer and surface absorption, the lumped capacitance model and everything, as you can see, and then compare the radiative results versus the convective heat flux behavior from Lab 4. And here's my experimental setup. As you can see on the very left, there you can see blue, which is actually the UV lamp being on. And I don't know if you've ever put your hand underneath. They can get quite hot and warm. And so my model is basically the configuration one, which is the wooden block and then the aluminum plate and then the heat flux sensor on top at the very top. And so that would be my sandwich. And then I would basically put it underneath the UV lamp and do data collection for 70 to 80 seconds and everything. And so my experimental procedure is pretty simple. Start data recording and then stick the sandwich underneath the UV lamp, record everything, and then save it, and then you would go through MATLAB and do your analysis and all that stuff. And so basically my data collection, I basically had like a range around 75 seconds and stuff, and I had a T air constant of 23 degrees Celsius from the back of the classroom or the lab and everything. And here are the actual graphs and results from my Lab 11 experiment and everything. And as you can see from the plot, the heat flux is gradually increasing, and then it plateaus and everything like that. And I found that my average heat flux was around 207.8 and stuff. And here is my temperature versus time graph, where you can see there's a very steady rise, and then it goes to around 29.4 degrees Celsius and everything. And this graph is pretty consistent with the heat input from the UV lamp and everything. And at the very bottom, you can see the ambient temperature is 23 degrees Celsius and everything. And then here is my heat transfer coefficient versus time graph, and it is quite a little bit messy and everything, but it does stabilize to around 32.8 and everything. And this does reflect the balance between the absorption radiation and the actual convective losses from my sandwich and stuff. And so here is just a table and of all the values and everything that I've calculated and stuff. And so the discussion that I got and basically thought about is that the UV lamp heating was effective, but it had less it was less intensive than actual foil heater from Lab 11, which I was surprised about. And then compared to Lab 4, it did have a slower temperature rise and everything. Again, it was to my surprise. And I think it was the limitations of the UV lamp. I thought it was pretty uniform, but I don't think it's as uniform as it could be potentially. And then from my feeling from just my hand and like feeling it on skin, I thought the UV light was very intensive, but apparently it was not. And so from the conclusion that I can draw from my Lab 11 just through the data processing and everything like that is that radiative heating method is viable and everything like that, and that the lumped capacitance model is viable as well for analysis, and that if I were to ever do this lab ever again, I would definitely have a better way of dispersing the UV lights and also definitely increase the actual lamp power of the UV. And that does bring into consideration of safety and everything like that because it is very powerful. And here are my references. Thank you very much.